last time. So geometric sequences have to do with this little formula that's called common ratio result, right? So we were multiplying by that R, and I think it's nicely shown here on the page where we produce next term when we times by R. So multiply by R. You multiply by R once again, and you get another result, and you multiply it again and you get another result. So that's how we produce next and next and next and next terms. So let us do exercise 81. Thanks for reminding me. And again, if there's any other question, please don't hesitate, ask. If you're working on some homework assignments and need help, I'm here to help you. So exercise number 81 says, find A6. A6, and you have the first term A1 and common ratio R. So we need to recall the formula for the nth term of the geometric sequence that deals with the first term multiplied by R raised to the power of n minus 1, one less, n minus 1, right? So looks like I'm going to have to use, instead of n, number 6, n is equal to 6, like that, right? And I also gonna have to use, instead of A1, like they gave here, number -2, and instead of ratio R, number -3. So let me write down the answer, which is A6 is equal to A1, or -2, multiplied by R, which is -3 raised to the power of 6 minus 1. So this is my sixth term of the sequence. And of course, it needs to be simplified a little bit. So let me do that. So I'm going to multiply -3 raised to the power of 5, right, by number -2. And, well, I guess calculator will be at use in here, because otherwise you're going to have to multiply -3 with itself 5 times. So we used to put this all in the calculator. So if I get this number -2, right, and times this by, in the parentheses, by -3, which is raised to the power of 5, then the result will be coming, and it's some kind of number, 486, and this is your answer. So I do recommend to use a calculator for these exercises, because multiplying -3 so many times with itself may definitely cause some mistakes, right? But anyways, that was the exercise that used the formula for geometric sequences, and the formula is produced here on the previous page, the one that we just looked at. So it's right there, the one shown in the nice yellow box. So that's the one that I also copied. So it turns out, when you know the formula, then all problems pretty much are solved, because all you really need is to plug some numbers into the formula. That's really all it is, right? So anyways, I hope that you are doing exercises, and I hope that you, if not, planning to start doing them over weekend, right? And if you didn't get 486, well, you can do another exercise very similar to it, as a little extra credit exercise, and send me that even problem, and I'll work to it by email sometime over weekend, right? So looks like this section was dealing with formulas, and that's pretty much all we need in here. Let me, I guess, move to the next chapter. We spent so much time with chapter 5, so you're probably tired of it. So now we can just move to the next chapter. So you don't have to do all this summary review and summary tests, exercises. Just look at the sections at the and problems at the end of each. So we're moving now to the next chapter, which is chapter 6, that talks about various formulas. And it's not surprising, we just saw some formulas. Let me clean all the code here real quick. So I'm sharing the screen once again. So I already wrote some formulas for you before, and well, here they show various possibilities, such as, for example, in page here, I try to highlight with blue, formula x plus 2.5. So there's some kind of formula that wants you to plug number for x and you get some result out. So let us take a look at the exercises in this section, because I'm sure this is familiar because it works with formulas and also it works with so-called order of operations. Also, you can see these properties that we already talked a little bit about. Remember, there were commutative and associative property, and we had those commutative property for addition and for multiplication, as well as associative properties for addition and for multiplication. And commutative property says that numbers commute. So let's say if you add 2 with 3, the same result will be if you add 3 with 2. So this commute. So you can switch these numbers around. In both cases, you get 5. Multiplication property says if you multiply 2 and 3, you get the same product as if you multiply 3 by 2. And we all know that and heavily utilize. Associative property here says that it doesn't really matter on the way you put parentheses. Remember, we had this also with 3 numbers, like 2 plus 3 plus 4. I can treat the same way no matter how I start to put parentheses or no matter how I start to add these numbers. Let's say if I put 2 and 3 first, or I put 2 and 3 last. My results are not going to change. My results are going to stay exactly the same. So that's the idea of this associative property. So you can move parentheses from front to the end, to the back. Analogous with multiplication. So associative and commutative properties work only with additions and with multiplications. And you can see the multiplication here. Right? So anyways, distributive property says distribute. And that's probably something that you already enjoyed a lot before, right? Let's say multiply 5 by parentheses or distribute 5 and get result such as 5 times 3 equal to 15 and 5 times 7 is equal to 35. And you can distribute this and over addition and over subtraction. So you don't really care what operation you have inside of your parentheses. You just go ahead and distribute, and that's the way to go. So it looks like these things are the ones that I already talked about. And section 1 of chapter 6 actually goes over these ideas once again. So let me go to this exercise set that appears at section end as usual. So let me clear this a little bit so you can make a print screen if you feel like it, and get the exercises done, such as first group of problems that says evaluate expression. And it's all about plugging the numbers in some particular exercise. So let me do one problem like 11 to see how we used to do this in various math classes. So exercise 11 here says utilize -2 instead of x. So all I have to do is put -2 inside of parentheses and square it. So notice that I didn't write x I need to put a number -2 instead of it. So I want to make sure that -2 will be squared. And well, now it's time to calculate to actually multiply -2 with another -2. Square means do it twice. You also have a minus in front here, and there is still -6. So please notice that these three minuses will give you a minus. So I still have -4 and also -6, which is going to be negative number 10. Right? So we have ourselves the result produced. We put 4 and 6 together and get 10, but the whole thing is negative. I say, Alex, I could just put this in a calculator and get the same answer. Yes, yes, you could do that. So plug numbers in. Sometimes, like in exercise 29, you have two numbers to plug in. Here we have n, x, and y in this expression. And notice there are two letters also present here. So why don't I try to do that as well? So I already know that we usually put parentheses. Sometimes we don't need it, like here, when x is positive number 2, we don't really need parentheses. But in the previous exercise, when I was dealing with negative numbers, I used parentheses for just in case. So here we have 2 times x times y. So whenever someone wants to be on the safe side, they put parentheses. So they put 2 instead of x and 3 instead of y, just like that. And then for the last term, we have positive 5y. So instead of y, which is squared, I will use number 3. So I replaced all numbers. I had all letters, x and y, with numbers they gave me. And at that stage, I can just use a calculator and get the result. So it looks like 2 squared is 4, so 3 times 4 is 12, right? Here we have 4 times 3, which is also 12. And here I multiply 5 by 9, which is 45. And then I need to add these 3 numbers and see what we get for the result. So it looks like to add 12 and 12, I get 24 and 45, which is going to be 69. Or you could just put in the calculator and get the same answer. So formulas, that's how this section is called. So we have various formula-like expressions, and we plug the numbers in. Please notice that's the same exact thing I did previously when I worked with those sequences, right? Just like we had for the quiz, I had a sequence and I plugged in some numbers, plugged them into the sequence. Someone may wonder, how about problem number 33 that also has a formula, but we have fractions? Well, doesn't really matter. You will replace those numbers in the fraction, and that's really all you need to do. So let me do this here on the right side. So I'm going to produce this fraction, and x will be -2, so I need to put it in the parentheses, right? I have 2 times number -2 here in the parentheses. Also add it with 3, so it'll be +3, and we multiply it by y, and instead of y, I use number 4. So it'll be 3 times 4. Notice that 4, you don't need in parentheses because it's positive. But since you're dealing with -2, you want to separate it from positive to make sure that it's really multiplied. And that's why I put parentheses, to make sure that I don't forget. Like in denominator, I probably don't really need this parentheses because I have -2 and +1. And this is going to be the, just, you don't have to put parentheses around -2. One can say, what if I still put it? Well, doesn't matter. It's not going to make much difference. So anyways, we're dealing here with a number -4, right, on the top, which is added with 12 in numerator and divided by -1. So let's see how we proceed here. 12 minus 4 will be 8, which I divide by -1, and the result will be -8. So it looks like I have here another little answer. So the point of story, we always plug everything into the formulas and get some numbers out. And that's the way to do all of the exercises here. Well, looks like we can take a look at more problems in this little section that tell us to distribute, to get rid of the parentheses. So let me try problem like exercise number 47, for example, that says, how about if you distribute 4? Just like that, just multiply by 4. Well, looks like I have to multiply by 4 these terms, and I get 8x, and I get -12 next to it, and that'd be my result. So looks like in this section, we don't really do anything new, but it's not surprising. Usually first sections of every chapter are just going over the stuff that you are familiar with, right? So 8x and -12 is our answer. And I cannot put them together because 8 has x, but 12 does not, right? So we have two numbers, but we don't have any like terms, people say, right? So you just leave the answer like that. Someone can say, Alex, problem number 59 has those brackets and parentheses. Does this make any difference if we have brackets or parentheses? And the answer is no, they're just grouping symbols. And I have to start with inside of my innermost grouping symbols, and innermost will be the parentheses, which is inside my brackets. So when I'm looking at this in exercise, then first thing I'm going to do is I'm going to get rid of the parentheses. So I'm going to have a 4y subtracted from 3. And then I also plus 5 at the end. So this is going to be my first step here, because I cannot really subtract 7 and 4. Some people will say, Alex, why not? Well, the answer is because we have multiplication here, right? 4 is multiplied by parentheses. So I must multiply first. Remember, order of operations, we have to multiply first. We don't start with subtractions. Actually, subtraction is the last thing I have to do here, right? So we don't do it first, we do it last. So what would be the next thing to do? Well, looks like inside of my grouping symbols, I have 3 and 5. So I'm gonna add them and get 8. So let me see what be inside of these grouping symbols. I get 8 here. And there is still -4y next to it, just like that, -4y. And this is what I'm gonna have to multiply by 4. So now when I copy the 7 minus 4, I will have to distribute 4. See, 4 must be multiplied. 4 is not subtracted at all. In fact, after you multiply, you will see that this number 4 is going to be turning into 32, 4 times 8, you see? 4 times 8 is 32, and plus 4 times 4, which is 16y. So it looks like we took care of our grouping symbols. Remember, parentheses or brackets, whatever grouping symbols are, they always have priority. So there's two numbers I subtract on the first step, and I get -25, right? And looks like that'd be it, because 16y stays separately. It has a y with it. So I'm going to end up with a -25 and 16y, and that will be my result. So I hope that this type of exercises is very familiar to most people in class. If you forgot how to do them, well, do a little bit more. if you're already familiar with them, maybe do another problem from this first group of exercises and then from another group of exercises and move on to the next page. The next page, let's see what it has there for us. It looks like on the next page, there is nothing because practice plus is what we skip and just a couple of more exercises, actually one more that you can try on your own. So we really concluded with the first section of chapter 6. How about that? Just simplifying expressions, and that's all we really did. Well, next section, 6.2 is called linear equations. So now we'll be solving various equations here. And equations are completely different type of work. Why is that? Well, because equations have equal sign. Let me clear all that. So I'm going to stop sharing and then share my screen again. And now the key difference with this section and the previous one is because now I have equal sign in my exercises. Like here, for example, I have equal sign. In the previous section, though, remember, we didn't have equal sign in the problems. So all we could do, we plugged numbers in. But here, there is no number to plug in. Here is equation. And this equation is what I'm going to try to solve. To solve means to find unknown x. And they actually solved it here for us. You see it? X is 11. In fact, one could guess that 11 minus 3 is equal to 8. So the difference with equations and the problems in the previous sections, the exercises that you had to simplify, is that equations you can solve. You see, equations is what you can solve. And after you solve equations, you find x. How do we solve equations? Well, there is a special way to do this. The way says you need to do same operation on both sides of your equation. So on the left side, looks like they added 3, you see it here. And on the right side, they also added 3. So we do same operation. We increased both sides of equation by 3. Or you can decrease both sides of equation by 7, like for the next one to find x, I just subtract 7. And this will leave me with x on the left side and number 22, actually negative, right? Negative 22 on the right side. So solving equations means to find x. And you can add the number to both sides. You can subtract the number to both sides. Or you can also divide, like here, you can divide both sides of your equation by 6, right? So you get x equals to 5. Divide by the same number, again, on both sides of your equation. So as long as you do same operation on both sides of equal sign, then it's fine. Notice that in the previous section problems, we didn't have 2 sides. We had just 1 side, so we couldn't really do the same operations on both sides of equations. And that's the major difference in these exercises. So I'd like to go to the problem set for this section and do a couple of equations. I'm sure that you already saw this kind of exercises before, right? It's very, very popular. Equations are everywhere. So let me try one of these here, like exercise number 11, for example. To start, let me scroll this down a little bit. So exercises on this section. So I'll do problem number 11. So how can we find x when we do exercise 11? When you say, Alex, looks like to find x, I need not to have minus 8. So I'm going to divide, right? Divide both sides of my equation by that number, negative 8. And see what we get for the answer. And for the answer, we're going to have a negative sign because we divide positive by negative. And as a result, I get 1 on the top and 4 on the bottom. So the answer will be negative 1/4. You say, why did you get 1/4, Alex? Well, because 2/8 is the same as 1/4 because you can divide n2, n8 by the same number 2. Do you know that? So we simplify. That's called simplify. And we should always simplify. Someone can say, Alex, I did just divided 2 by 8 using calculator and I produced 0.25, which is same as 1/4. Well, technically, yes, that's also the answer. 0.25 is same as 1/4. So I wouldn't say it's not correct. So you can technically do it like that as well. So equations, we solve them by doing the same thing on both sides. So let me try another exercise here. Let's say problem number 26. I want to solve equation number 26 exercise here. And in order to solve that equation, I should also find the x, right? Should also do same thing on both sides. But please notice that here we have x that appears n on the left and on the right side of equation. So what people want to do is they want to bring the x's to one side. So they subtract x. So they have 2x and minus x on the left side of the equation. So this way, I'm going to have the x's on one side. And then I'm going to have to bring the 7 over to the right side. So this way I get 13 here and x found. So x is equal to number 13. So we just solved another little equation. We found x, and that's really all I needed to do for this little exercise. X is found, x is 13, and looks like we're done. So reshuffle in terms, right? So bringing x's to one side, numbers to the other side is what I have to practice doing in here. Okay, so how about if we have parentheses? How about if there is exercise 33 that we gonna try to solve? Well, it turns out that I need to get rid of the parentheses. So I need to distribute the 2 like that, and then another 2 the other way. Some people can say, Alex, you could just divide by 2. Instead of distributing the 2, you can divide by 2. Yes, if you notice that, you will get a real good shortcut. But let's say you didn't notice it. Standard way will be to distribute 2 to solve this problem. So I'm going to get 8 and minus 6x next to it. And this will be equal on the other side with a 4x plus 2 times 5, which is 10. So it looks like here I have the new equation of the same exact type that I just had in the previous exercise, right? So I need to just bring x to one side and numbers to the other side. Let's do that. So minus 6x and minus 4x will come to it, right? We change signs of the terms when we bring them over to the other side of our equation. So 10 here and minus 8, that is also going to be on the right. So I'm going to get negative 10x here on my left side and positive 2 on the right. So I just collected those like terms, right? So next step will be to divide. I'll divide both sides by negative number 10, just like that. Put negative 10 in denominator and have the x found, and x will be some negative number that I can also simplify and write as 1 over 5. I divide by 2 and the top and the bottom. 2 by 2 is 1, 10 by 2 is 5. So we have another nice answer. So it looks like we are solving equations, and sometimes we can't solve them right away. So we do it little by little. So we actually distribute, so we get parentheses, and then we can solve, right? When I say, Alex, I'm looking at the other side of this page and I see equations that have denominators. Well, when I see denominators, what I do is I get rid of them. Let's say if I try problem like number 52 exercise. Look at that. Problem 52 has lots of denominators, right? And that really bothers me because I don't like those denominators. I want to clear those denominators. And it turns out that to clear those denominators, you need to know the lowest common denominator. We already saw those common multiples in the previous chapter. Remember, lowest common multiples. In fact, that's what you did on the midterm exam, remember? Lowest common multiple. You probably wondered why. Well, because of this section where we use these common multiples or common denominators to get rid of them. Please notice that the lowest from possible multiples will be 12. When you say that's the largest. Yes, so we take the largest of denominators and see that 12 works with every single one of these numbers if I multiply by 12 on the left side. And on the left side, multiplication means I have to times by 12 both pieces here on the left. And if I also multiply by 12 on the right side of my equation, remember, we have to do same operations of both sides of equations. So here I'm multiplying, same thing means you multiply, and you multiply by 12, so this cancels. And I multiply, so 12 and 12 cancel. 12 and 6 also cancel, and leave me with number 2, right? 12 over 6 is going to be 2. 12 I can also divide by 2 and get 6, so I put 6 up here. And finally, 12 I can divide by 4, so I get 3. So this way, my equation is going to be much nicer. This way, the equation is not going to have any denominators. Just look at this. After I cancel 12 and 12, I just have y left, so I put y, plus sign. Now there is 2, you see that pink 2 above, which is multiplied by 1, so I just have a 2. And that's it, equal sign. What's on the right side? Well, looks like we have 6 y's here, 6 y's, like that, right? 6 times y, and then minus number 3, then minus number 3, because 3 is all I multiply by 1. How do you like this new equation? Isn't that so much nicer? Right? Right away, I produced nicer equation simply because I got rid of all my denominators. So this one I can definitely solve. I can bring y, actually negative 6y to the left side, right? Subtract it. And minus 3 minus 2 will go to it on the other side. The 2 becomes negative, right? So negative 5 y's will be here on the left side, negative 5 y's, and minus 5 is still on the right. It looks like now it's time to find y, divide on both sides by negative 5, just like that, right? And now we have our result. Our result will be y is equal to number 1, just like that. So we solve the equation. So yes, looks like we are doing 2 sections today, because I hope they are familiar somewhat. And of course, if they're not familiar, well, try some problems and bring me questions on Monday, right? So let's do another exercise. We just solved this problem for y, so let's try another exercise, like say problem exercise number 57. 57 has another equation in it. 57 has denominators 5 and 4. So I'm wondering, how can I get rid of these 2 denominators 5 and 4? What my common denominator should be? And the answer is, it has to be 20, because 5 and 4 have nothing in common. So I just multiply 5 by 4 and get 20. So I'll put 20 here on the outside and times this on my first term, I also have to multiply -1 by 20. Did you know that? Because we multiply every single term of our equation by that same exact number, 20. And then I also have to multiply the right side by 20. So let us get rid of denominators. That's why we do all that, right? So I'm going to put 4 here. When I divide 20 by 5, it's 4, right? And when I divide 20 by 4, it's 5. Okay, so let us see what we're going to get. Let me continue with this here on the right side, here downwards. So 4 is left, right? So I just copy everything that I have, and it's multiplied by x minus 3. No more denominator. Minus 1 times 20 is 20. Then I put equal sign, and then x minus 5 is multiplied by 5. One will say, Alex, why did you put parentheses in here? Well, the reason I have to use parentheses is because this 4 must be multiplied by the whole thing, by and x and by minus 3. So I have to distribute that 4 over entire numerator. And that's why when numerators have differences or sums, we must use parentheses. Okay, so look at this equation for a moment. Doesn't it look nice? Look at this equation. No more denominators, right? And that's what we really needed so we can find x. So now we can proceed. Now I can distribute my numbers over parentheses because next step, next priority is for parentheses, right? Parentheses always have priority. So 4x and then minus 12 is next to it. There is still -20. And on the other side, I'll have 5x and minus 25. So no more parentheses, we just have a better looking equations. And someone can say, Alex, these two numbers, they can put together, it's -32. Yes, you can do that. I don't want to copy the whole thing just because of that, but yes, those are like terms, so you can put them together. Then what? Well, 5x I'll subtract from 4x, so I bring it to the left side as -5x, right? And this be equal to -25 and plus number 32. So this is my new result. This is my new little equation. So how can I finish up with this and find x? And the answer is now you need to just put these x terms together, right? And 7 is the right side because I subtract 25 from 32. So what about x? If minus x is 7, then I change signs on both sides of my equation and get x is equal to -7, right? -7 is the answer. So solving equations is another step that another popular procedure that we saw back in algebra classes. And my advice is, if you don't like this group of exercises, well, redo same problems I just did here for you. There's 2 exercises I just did. Well, try to get a clean piece of paper and do number 52 on your own. You can look at what I did and see if you get the same answer. And if not, we can do it again next time. I would say these problems are good practice exercises. I say, okay, next group of problems also has denominators. And the answer is yes. You can do the same exact procedure to do problems like number 67, for example. I say, what is the same procedure? Get rid of their denominators. Find the common denominator and multiply by it both sides. Like in 67, I can see 12, the larger one, and 12 will work and with the left side denominator and with number 3, because 3 will cancel nicely. When I say Alex, so you put parentheses here. Yes, to be on the safe side, but technically you don't need because 12 will cancel, right? So where should I proceed with this? Maybe here on the bottom. So maybe I put this little arrow. So I got just x minus 2 on the left side, right? X minus 2 is on the left side. And analogously, when I cancel my denominator, I'll just have 8 times 4 on the right side, because 4 is left to be multiplied by 8, and 8 times 4 is 32. Look at this group of problems looks much nicer, because it looks like we just get rid of those denominators and have much simpler looking equations. All I need is to add 2 on both sides of it, right? So you have to add 2 here on the left and on the right sides. And this will give us the answer. The answer will be x, which is equal to number 34, right? 34 is my result. So we solve various equations, and I hope that you saw this before. Maybe it's been a while, so some people may say I need to do a little bit more of them. Well, try to do some more. Notice there are lots of these equations in here. And if I look at the next page, well, it's going to be over. So next page you don't really need. So it looks like you just need one page for section 6.2 just to look at some equations. And I think maybe it's a good idea that you try to solve one of these equations on your own for a little quiz. I'm not going to ask you anything with denominators. Maybe problems like number 30 could be a fair quiz exercise for today. So let's do problem number 30 for today's quiz. Find x, right? Solve equation, find x, and as usual, just send me the answer for it in the chat. And after that, well, I'm gonna stop the recording because